evaluate these three samples, it's 3 liner sample, using the OptiTopo Expert software. This is the main user interface of OptiTopo Expert. We have this evaluation section. Here you put a comment. This comment will be stored in result files and plots. We have the result file where the reports will be saved. It is possible to select images you have saved before, which you want to evaluate with new settings. And when you have captured image, it's possible to press this calculate button. This section shows the results from the latest sample set. We have the OSD value, the amount of craters, fine craters, minus 1.5 micron, medium craters 3 micron, and coarse craters minus 5 micron. It's also possible to calculate user-defined craters with a different depth. After the calculation, you can open the result file. You can select if you only want to see the new results or if you want to see all results. This section, Capture Images from the L&W OptiTopo instrument. In this example, we have 3 liner sample. So I call them liner, this project. I press new. The first liner is named 115 gram. I press new. Put it in the instrument and press read sub area 1. Now the instrument are measuring this sample. It will take some seconds. And we will see the surface in the user interface. If we don't like this image, for example, if we have a defect, we can press this cross to remove it. But in this case, we want a second sub area. So we move the sample a little and press read sub area 2. I press the done button. Put a new sample in the instrument. This is called 140 gram. Press new and read sub area 1. No calculations is made in the instrument now. They are done later in this software. I think 1 sub area is enough on this sample. So I put in the last sample. This is called 175 gram. Press new and read sub area 1. I press done and also done on the project. We have the filter and settings menu. We can load previously saved filtering settings or change the user-defined settings. First, we have this crater and hill section. We can change the standard bandpass. The standard bandpass is from 0.01 to 0.5 millimeter. In this case, we have a larger scale here to see more large-scale variation. We can also select a different crater depth and hill height. It's also possible to change the wavelength to some. The standard OSD value is from 0.0625 to 0.5 millimeter. In this case, we want to see more large-scale variation. And it's also possible to save the new settings in a new name. There is a menu called Plot and Save Options. We can either load previously saved settings or change the plot and save settings. This menu is divided in several sections: plot map options, plot graph summary, and save result option. Let's start with the plot map options. Should we plot only the first sub-area in a sample set or all sub-areas? Should we plot the gradient map? It looks like this, showing the gradient on this sample surface. Should we plot the height map? Looks like this. It's scaled from +10 to -10 micron. Should we plot the crater map fine, ±1.5 micron, the medium, 3 micron, or the coarse one, ±5 micron? It looks like this. You can see the red parts are craters and some green parts are hills. Should we plot the intensity map? If you see something with your eyes, you could see it in this map too. For example, it's a dark spot here. We can also plot height map user defined with a different bandpass and different depth threshold. It looks like this. So here you can see some more large scale variation because it bandpassed 0.01 to 3 millimeters. It's also possible to plot the crater map user defined. It looks like this. And we can enlarge it to see it more in detail. And if we are very interested in this part, for example, we can magnify it. So this is a deep part, and this is some kind of hill. We have this section, plot graph summary. First, the surface variation, which is the same as standard deviation. We have the fine scale, also called OSD value. And the plot looks like this. We have the mid-scale variation and the large-scale variation. This shows the large-scale variation. We have user-defined scale and also intervals, also called octave bands. It looks like this. And we have the detailed plot, also called spectra. Looks like this. It's actually 66 values you can see here. And this plot is great if you want to see periodic variation, like wire marks. We select if we want to plot the craters and hills in the same plot, or only the craters, or only the hills. So we want the fine scale craters ±1.5 micron, the medium ones ±3 micron, or the coarse ones ±5 micron. And that plot looks like this. And as you can see, the first and the third sample has almost none, but the second has a lot. We can also plot user-defined craters, where you select the threshold yourself. We have the save result option. First the plots, and then the numeric values saved to Excel. For the plots, we can leave them on the screen. We can save them to Microsoft Word, save them as JPEGs, and save them as MATLAB files. And for the Excel values, do we want the sub-area information, or is the average enough? Should we save the surface variation intervals? The detailed surface variation? Should we save emulation for other instruments like PPS, Benson, Sheffield, and Enveco? And the use setup, which is the settings we used. To start the calculation, I press the Calculate button. Now the software will read the sub-areas we previously recorded. So it calculates the gradient map, intensity, the gradient, height map, and the user-defined height map. The crater and hill map, and the user-defined crater and hill map, and start with the next sample. To examine the result, press New Results. First, we look at the gradient report. You can see the project name and the comment and the date. So this is the first sample, and you can see how the surface look like, the gradient. This is the second sample and the third sample. And you can see it's a clear difference between the two samples. This is the height report. First sample, and its height scale plus minus 10 micron. The second sample is much rougher, as you can see, and the third sample is quite smooth. And here is the crater report. The red parts are craters and the green parts are hills. And you can also read the threshold used was plus minus 3 micron, and the percent above and below threshold is 2.3 and 3.96% of total area. This is the second and the third sample. And on the second sample, we find a lot of craters and hills. This is the summary plot. First, we have the OSD value, the fine scale variation for the three samples. Then we have the crater and hill values. Very little craters and hills on the first and the third sample, but quite much on the second one. We have the surface variation divided in wavelength classes from fine scale to mid scale and to large scale. We have the surface variation in the detailed plot. This is actually 66 values from fine scale to large scale. And if you have a periodic variation, for example from wire marks, you will see it as a peak here in the spectra. And you can see here, the ranking is shifting here in the large scale on these samples. This is the Excel file. The first tab is the summary tab. We have the sample name, the date, and the comment for those three samples. First, the OSD value, the fine scale variation, the mid scale, the large scale, and the user-defined scale. Then we have the crater fine, crater medium, and crater coarse, and the corresponding hill fine, hill medium, and hill coarse. And also the user-defined crater and hill, in this case plus minus 10 micron. I have made some plots from these values. They are not automatically generated, but it's quite easy to do so. We have the surface variation. This is the variation in octave bands from fine scale, mid scale to large scale. We have the detailed surface variation, fine, mid and large scale. And if you have a periodic pattern on your samples, you will see this as a distinct peak in the spectra. We can also emulate other instruments like the PPS, Benson, Sheffield, and Stylus Roughness and Veco. Then we have the same tabs for the sub-areas. So here you have more information. For example, the third sample, we have 2 sub-areas. You can see it has 2 lines here. And then we have tabs for the sub-areas for surface variation, detailed surface variation, emulate the instrument. And the last tab is the setup, showing the settings you used when you make the measurement. For example, area size and pixel size. This is the toolbox menu. This menu makes it possible for custom adapted analysis for different needs. In the expert OptiTopo, we have included one called Make Height Profile. Here you can load a height map. And you can also select manual height scaling. I select ±4 micron, make a replot, and here is the height information. We can select a row, and this will show a plot along this row with the height information. We can also select free if we are very interested in a small part here, for example, this part. You can see we have a high peak here from this defect. This is the instrument menu. It is possible to select the size of the image field. Default is 32 by 32 mm, but if the sample is too small, it is possible to use 16 by 16 mm instead.